Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about the question bank on module 4 for the statistics for data science. So the very first question is that what are the characteristics of statistics? So statistics are aggregate of facts and then should be numerically expressed and should be also going to affect to a marked extent by multiplicity of causes and reasonably standards of accuracy in enumeration and estimation or collection. And these statistics are going to be collected in systematic manner, and these statistics are going to be collected for a predefined purpose as well. So the statistics are mainly used for aggregation of the facts and then numerically expressed, and we can able to are going to be uh, improve the accuracy and then estimation and then collection. And mainly the statistics are going to be collected in systematic and then in predefined purpose. So normally the statistics is going to be used for collection of data and then classification of data, presentation, analysis, and then interpretation of the data. And what are the various statistical methods we're having? So some of the statistical methods we're going to have statistical method and then applied statistics. So again, this one is further divided into descriptive statistics and scientific statistics. So mainly the statistics will be two types. So normal statistics and then applied statistics. So again, these applied statistics will be of two types, like descriptive and then scientific. So describe about sampling. So here the sampling is nothing but a process of selecting the observations to provide an adequate description and inferences of the population. And the sample is nothing but it is a unit that is going to be selected from the population, which should also represent the whole population. And the main purpose is to draw the inference. And why sampling and sampling frame? So the list of population from which the sampling is chosen is nothing but the sampling frame. And the sampling process will be looks like this. So we're going to have a population here. From this population we're going to select the population frame. So from this we're going to extract the sample, what we're going to obtain this, so that should be called as sampling process, and this sample should be called as the inference of this population. And the sample mainly represent what you actually observe in the data is nothing but the sample here. So normally there are two different types of sampling, like homogeneous population and then heterogeneous population. Homogeneous means within a specific thing we can able to extract the some portion of that population. And heterogeneous means it should be of different people and then different samples are going to have, and the unique of that group of that each sample have to be extracted. And next one is that how we're going to describe the sampling design process. So sampling design process will be looks like this. So initially you have to define the population, and from that population you have to determine the sampling frame, what should be the size of the frame, then how many number of samples are going to be occupied, and from them we have to apply some sampling procedure. So either you can able to done through probability sampling, or I can able to apply through the non-probability sampling. So again, this non-probability sampling and the probability sampling is equal to is used to determine the appropriate sampling size, and then we finally have to be execute the sampling design. So initially what we have to do is initially we have to be define the population here. So from this population we have to determine the sampling frame. So from this sampling frame there are different types of sampling methods we are going to choose. So simple random sampling, stratified random sampling, cluster sampling, systematic sampling, and multi-stage sampling. And similarly are going to have convenient, judgmental, quota, and snowball sampling. So like this we are going to have different types of samplings. And next one is the describe about the probability sampling. So the probability sampling is nothing but it should be of different types. So first one is simple random sampling. So all the subjects of the frame are given to the equal probability, and then have to example is that generating a random numbers. So all the subjects the frame should be of equal probability, then it should be considered as a simple random sampling. So example, randomly generating the numbers. And simple randomized sampling is going to have some of the advantages. So minimum knowledge of population is needed, and then it should be easy to analyze the data. Whereas the disadvantage is that so it should be low frequency of use and does not use researcher expertise and large risk of random error. So simple sampling means should be minimum knowledge is required. That much experts is not going to be used for implementing this random sampling, and it should be easy to analyze the data. When it comes to disadvantages, so it should be low frequency of use and not require the researcher's expertise, and larger risk of random error is the thing. Stratified random sampling. So here the population is going to be divided into two or more groups, what we're able to call it as strata, and the subsamples are randomly selected from each other. Okay, and so here what I'm going to say that so here we are going to have the simple uh, example. So here we are going to have list of clients. So again, this one should be all the clients from Americans and Africans and Hispanic and Caucasians like this. So again, this one what we call it as a strata here, and then we are going to be extract the some specific people of that you can able to filter as the stratified random sampling. So here the population will be of different groups, what we can able to call it as a strata, and the samples of random sampling from each strata, what we can able that. So then what are the advantages and disadvantages of this? So the advantage is that so it should able to assure the representation of all groups in sample population, and then characteristic of each stratum can be estimated and comparisons can be made. And disadvantage is that it should able to requires accurate information on proportions of each stratum, and stratified list costly to prepare. So stratified random sampling means so here we're going to be assure the representation of all groups in sample population, and the characteristics of each strata can be estimated and comparisons can be made. And disadvantage is that we should able to require more accurate information, and it should be the list stratified list should be costly to prepare. And next one is that cluster sampling. So here the cluster means that so the population is going to be divided into different groups. So what one can able to call it as clusters like families. And simple random sample is going to be taken from each cluster. Suppose this is the one area of section 2, and this is the section 1, and this is another section area. So I'm going to group the pickup of samples from each section. So red color houses, let it be, and then blue color houses, and another section should be green color houses like this. I can able to specify. So I have to make it as a group. So for each sample, and this is the other section of houses. So the population is there, so from that population different areas is there. So what I'm going to make that is so within this group, so all the similar families is have to make it as a one cluster, and that should be treated as a cluster sampling here. So what are the advantages of this one means it can easily estimate the characteristic of both cluster and population, and disadvantage is that it should be costly one. To reach an element in a sample should be very high, and each stage in sampling introduces the sampling error. And next one is the systematic random sample. So here the systematic random sample is going to be order all the units in sampling frame, and every nth number on the list is going to be selected. So in a series of n list of n numbers, so I'm going to select the third sampling here. So from that again next third sample, and from that here next third sample. So the systematic way of selecting the sampling from the population is called as a systematic random sampling. So what are the advantages here? So advantage should be moderate cost and moderate usage, and simple to draw the sample and easy to verify. And the disadvantage is that periodic ordering is going to be required. And in multi-stage sampling, so here we're going to have different kinds of clusters, and from that each cluster Again, we are going to identify the subclusters. So this thing, identifying the subcluster from the main cluster should be treated as a multi-stages sampling here. So the multi-stage sampling is that, so initially you have a group of clusters here. So within this group of clusters C1, C2 and C3, again I'm going to identify the subcluster SC1, SC2 and then SC3. So identifying these subclusters from each cluster should be treated as a multi-stage sampling here. So what are the advantages of this one means it should be more accurate and more effective, and the disadvantages is nothing but it should be costly one, and in each stage in sampling introduces the sampling error. So where the most stages that since there are, it should be, there may be a chance of getting errors. And then the next one is the describe about the non-probability sampling here. So again, these non-probability samplings will be of different types. So the what should be the first one is non-probability samples. So the probability of each case being selected from the total population is not known, and the units of samples are going to be chosen on the basis of personal judgment or convenience. And there are no statistical techniques for measuring the random sample in a non-probability sample. So here this probability and non-probability. So when it comes to non-probability, the probability of each case being selected is from the population is not known. That should be treated as a non-probability sampling, and the units of the sample are going to be chosen based on the personal judgment or based on the convenience. So there are no statistical techniques that are available for measuring this kind of sampling error in non-probability sampling. So some other different types of non-probability sampling will be convenience sampling, quota sampling, judgmental sampling, snowball sampling, and self-selection sampling. So what is this first one, convenience sampling? So convenience sampling involves the choosing respondents at the convenience of the researcher. The advantage is that it should be very low cost and extensively used and understood one. And comes to disadvantages, the variability and bias cannot be measured or controlled, and projecting beyond the data sample is not justified, and the restriction of the generalization. So these are the different types of uh, advantages and disadvantages of convenience sampling. And then quota sampling is that, so this population is going to be segmented into mutually exclusive subgroups which can be able to treat as certified sampling. And so the advantage is that when this one is going to be used whenever the research budget is limited and extensively used and understood, and no need of for listing of population elements. So when it comes to disadvantages of this, the variability and bias cannot be measured and controlled, time consuming, and then protecting data beyond the sample is not satisfied. Judgmental sampling is another thing. So here the researchers employs is a more expert judgment, and the advantages is that there is an assurance of quality response and meet the specific objective. And disadvantage is that the bias selection of sample may occur and time should be a time consuming process. So these are the two advantages and disadvantages of judgmental sampling. And next one is that snowball sampling. So here the researcher is going to start with a key person and introduce the next one to become a chain. So the advantages is that it should be low cost and should be useful in many specific circumstances and for locating a rare population. And disadvantage is that not independent, and then projecting data beyond the sample is not justified. And self-selection sampling, so it occurs when you're going to allow each case usually individually to identify their desire to take part in the research. And advantage is that it should be more accurate and should be useful in specific circumstances to serve the purpose. And disadvantage is that it should be more costly to advertising and mass are going to be left. So this one should be more accurate one and should be best in many of the circumstances to serve the purpose. The only disadvantage is that it should be more costly due to advertising. And next one is the describe about sampling error. So the some of these different types of sampling errors are available when the sampling is going to be conducted. So some of the sampling errors will be when we're going to rise due to the user sampling surveys known as sampling errors. And two types of errors are going to be identified. So first one is biased errors and unbiased errors. So in this biased errors, so due to the selection of sampling techniques and the size of the sample, and unbiased random sampling errors. So there should be a differences between the members of the population included or not included. So these are the two types of errors that may arise. So first one is biased one. So due to selection of the sampling techniques, the size of the sample is more than the biased errors is going to be appear. And unbiased errors or random sampling errors means so whenever we are going to make the differentiation between the members of the population, whether it should be included or not included, then you have to make use of this unbiased errors may appear. So what are the various methods of reducing the sampling errors? So first one is the specific problem selection. So based on that, we have to choose what type of method is going to be applicable, and then systematic documentation of related research and effective enumeration and effective pre-testing, and then controlling methodological bias and selection of appropriate sampling techniques. So these are the various different kinds of sampling methods that are available to reducing this sampling errors. And so first one is the specific problem selection and systematic document of related research. And the next one is effective enumeration and effective pre-testing, and then the controlling of methodological bias, and then selection of appropriate sampling techniques. When it comes to non-sampling errors, so normally this non-sampling errors refers to bias and mistakes in the selection of the sample. And what are the various causes for non-sampling errors will be sampling operations and inadequate of response, and then misunderstanding the concept, and the lack of knowledge and concealment of the truth, loaded questions, processing errors, and sampling size. So because of these main reasons, the errors from non-sampling is going to appear. So normally this non-sampling errors refers to bias and mistakes in the selection of the sample mainly. So some of the common reasons means, so if I'm going to perform some of the sampling operations, or some the response is not that much adequate, and misunderstanding the concept and lack of knowledge and concealment of the truth, loaded questions, processing errors, and sampling size. And what are the various measures of central tendency? So before going to see this central tendency, well, first of all, you have to note that the data with a one variable should be treated as a univariate, and the measures of central tendency are the measure that is going to describe the middle of the data. Okay, so mainly what are the various measures of central tendency will be mean, median, and then mode. And mean is nothing but the adding up of numbers and divided how many numbers are there, and the median means that should be the middle number what I'm going to identify among the list of n numbers. So for that we have to place the numbers in numerical order and find the one in the middle. So if there is an even number average, then the two middle numbers have to be considered. And mode means the number that occurs more frequently should be treated as the mode here. Suppose if I'm going to have a list of numbers like 1, 2, 3, 4, 1, 2, 3, 4. So how can I able to calculate the mean? The sum of all these numbers 1 plus 2, 3, 6, 10, 20 by 8. And then median means, so what how the median is going to be calculated. So have to be arrange all the numbers in the sorting order, and you have to calculate the middle of the element. So this should be the middle of the element, that should be 2. That should be the median of this. And Mode is number, nothing but the number which is going to occur more frequently. So that should be considered as the mode. And suppose if I'm going to have another 4, so the mode of this series will be 4. So mode, median, and then mean. So like this, we're going to be calculate the various measures of central tendency. See the example, if I'm going to have a list of n numbers, so we're going to calculate the mean. So first one, you have to be calculate the mean by adding up of the numbers, and then by adding this I'm going to get 160, and this one is going to be divided by the number of numbers, 160 divided by 11, so this is the mean value of the series. So how to calculate the median here? So for this we have to be write all the numbers in sorting order, and from this we have to calculate the middle of this element. So 1 2 3 4 5 6 7 8 9 10 11. So 11 means 15. So 15 is the middle, that should be the median. And mode means the value that is occur more frequently, that should be considered as the mode. So among the list of n numbers, so the 10 is repeated 3 times, so that should be the mode of the series. Like this, we are going to calculate this various measures of central tendency. So with the values of mean, median, and then mode. So which measures of central tendency is the best one? So that is the question. So there are many times so when the one of the measure of the central tendency will be better describing the data. So the mean is going to be used whenever the data is spread out and you want an average of all these values. And the median is going to be used when the data contains outliers. So outliers are the values does not fit of the rest of the data. And the mode is going to be used whenever the data is tightly clustered and around one or more two values. So that should be the various measures of central tendency. Among the based on the criteria, this particular measure is going to be calculated. So mainly this mean is going to be calculated whenever the data is spread out and you want to find the average of all the values, then only you can able to use mean. And median means suppose we have a cluster of the data. So all the cluster of these elements should be same property, and some of the cluster that may be lies outside the cluster. So this one should be treated as outlier. So it should not have, do not have any kind of relationship between them. So that should be treated as the median. And mode means whenever the cluster is there, so the value that occur more frequently. So what is the most occurring element? 1. So that should be the 1 should be the mode of the series. And next one, measures of variance and dispersion. So we're going to calculate what is the equation we have. So first one is the numerical value, so associated with how the spread of the data is. So for this we have to calculate the range. So largest value, smallest minus smallest value. Suppose if I am going to have the series 20, 30, 50, 60, 80, 90. So among this, what is the largest value? 90, smallest is 10. Otherwise, if I'm going to have 10, 35, 25 also. So among this, what is the largest one? 90, smallest is 10. That's so 90 minus 10, that should be 80. So the range equal to 80 here. And then how we are going to calculate the variance and then standard deviation. So the variance or standard deviation differs how much the data value differs from the mean. So that one you have to consider, that should be the variance and standard deviation. So how much the data value that is going to be differ from the mean. So if I am going to have the data, so these are the x1, x2 values, x3, x4 and x5. So how to calculate the standard deviation? That should be square root of, so what is the x1 here? 25. What should be the mean value? So the mean value we are going to calculate. So 25, 35, 10 plus 30 plus 50 plus 60 plus 80 plus 90 by 4, 5, 6, 8. Suppose 480 is there, so 8 and 8 is the mean. So at that time, what I have to do? So 25 minus 80 plus 35 minus 80 whole square, and then 10 minus 80 whole square. So like this, we're going to calculate the standard deviation. So that should be divided by total number of values. So how much? 8. So what is the value I'm getting? That should be the variance and then standard deviation. So for finding the variance and standard deviation, so what are the steps you have to be followed? So for finding the variance sigma square, so first we have to calculate the mean. Find the difference between each data value and the main value, and then square each difference, adding them up, and then divide by the number of data values. And for standard deviation, if I'm going to apply the square root of the variance, then automatically it should be the standard deviation. So see here, so 1, 2, 3, 4, 5. So mean, so 3, 10, 15 by 5. That is equal to 3. So how we are going to calculate the mean? So 1 minus 3 whole square, 2 minus 3 whole square, 3 minus 3 whole square, 2 minus 3 whole square, and 5 minus 3 whole square, divided by total number of values. This should be the variance. If I'm going to apply the square root, then it should be standard deviation. So the example, how we're going to calculate the measures of variance. So first one is that 3, 5, 7, 9, 11. So first we have to calculate the range. So there is the largest minus smallest value. Largest is this and smallest is this. So from the standard, find the standard deviation. So before that we have to find the variance. So and the mean is equal to the sum of all the values divided by total number of values. And so have to be apply for each attribute, you have to subtract the mean value. So 3 minus 7, 5 minus 7, 7 minus 7, 9 minus 1, 11 minus 7. So once this one is up done, we are going to get the value that should be divided by sum. So and then I'm going to get the sigma square, that should be variance. And if I'm going to apply this 8 square root of variance, then that should be standard deviation. So like this, we're going to get all the values here. And next one is that, so describe about hypothesis testing. So what is hypothesis testing? So hypothesis testing refers to making an assumption called hypothesis about the population parameter and collecting the sampling data and then calculating sampling characteristics and all. So this and all will be treated as a hypothesis testing. And different types of hypothesis testing we are going to have. First one is null hypothesis and second one is alternative hypothesis. And a null hypothesis is going to be presented through H0 and H1. So null hypothesis is going to represent a theory that has been put either forward and that is going to be true, or because it should be used as a basis for the argument as well. An alternative hypothesis is going to be presented as HA. So this is the statement what the statistical hypothesis is said to be established. And suppose if I'm going to have a hypothesis like this, null hypothesis, then alternative hypothesis will be like this. So describe about the confidence interval. So the confidence interval is nothing but it should be a parameter number that is going to describe the population statistic, and statistic is the number that is going to describe the characteristic in the sampling data. So parameter is the number. So normally this should be a parameter number which is going to describe the population statistic, and statistic is also a number which is going to describe the characteristics of the sample. So there are different types of statistics like inferential statistics and statistical statistics. So in inferential statistics, we have to draw the conclusion from the data, and then for the sample, we have to describe the data. So use sample statistics to infer the population parameter like estimation and hypothesis testing. So these two are going to be considered as the population parameter to estimate the statistic. So inferential statistic, by making use of this inferential statistic, you have to draw the conclusion from the data, and we where we can able to use some of the sample statistic for inferential population parameter will be estimation and then hypothesis testing. So how this confidence interval is going to done? We have a data collection that should be treated as the raw data, and from this data collection we have to apply the descriptive statistics, so either in the form of graphs and the measures, and from that we are going to apply statistical inference, which is going to perform estimation and hypothesis testing, and finally how to make the decision. So again we have to take the raw data or information how to be constructed. So the data collection and descriptive statistics is something different. So previous things should be inferential. So this one is the descriptive statistics. So mainly these graphs and the measures should come under this descriptive statistics, and we are able to make the decision making. So estimation. So here estimation means that so the numerical values are going to assign to the population parameter using sample statistic, and the sample mean is going to be estimated at x bar, which is going to estimate the population mean, and sigma variance, sample variance, is going to estimate the population variance that should be denoted to sigma square, and sample standard deviation S is going to estimate the population standard deviation that should be denoted as sigma, and the sampling population P cap is going to estimate the population proportion of P. So like this we are going to estimate the confidence interval. So what are the steps in estimation of a confidence interval? So select the sample first and get the required information from the sample, and calculate the sample statistic, and then assign the values to the population parameter. So the steps in statistics should be select the sample, get the required information from the sample, calculate the sample statistic, and assign the values to the population parameter. So the sample statistic is going to be used to estimate the population parameter called what we can able to call it as estimator. And this estimator is the rule that we're going to tells us how many. So sample statistic is going to be used to estimate the population parameter what can able to call it as estimator, and estimator is the rule that tells us how to calculate the estimate, and then how we're going to be generally expressed as the form. So this estimator is the rule that tells us how we're going to calculate the estimate, and then it is generally expressed as the formula. So for this confidence interval, so we're going to have mean, variance, and the proportion. So the mean is going to be represented mu, sigma square, and the proportion. Then estimation value should be x bar. Estimation value is x bar, and then variance is x square, and the proportion is p cap. So what is the equation for calculating the mean? So x bar is equal to 1 by n into sigma x, and sigma x square minus n is equal to n into sigma x square divided by n minus 1, and p cap should be written as x by n. So here the mean for this there is a formula for calculating this confidence intervals, the mean, variance, and the proportion. So the mean is going to be calculated through the symbol, and the equation is this, and for calculating the variance, sigma x square minus of 1 by n sigma x square by n minus 1, and proportion p cap should be written as x by n. So what are the two types of estimates we are going to have? So first one is point estimates, and then interval estimates. So what is this point estimate? So point estimate is nothing but a simple sample statistics that should be used to estimate the population parameter, and the graph of this point estimate would be looks like this. So we're going to have one sampling distribution, and population parameter we're going to have, and population distribution curve, and sampling distribution curve, and then in between them what we're going to have that should be the point estimator. A simple statistic normally is going to be used to estimate the population parameter. And next one is confidence interval. So the interval is going to be calculated among the sample statistic. So the middle of the first graph and the middle of the second graph, in between the area what can able to call as the confidence interval. So where it is going to be started and ended. Uh, so this confidence interval is calculated around the sample statistic. The next time about point estimate. So it should be a number that is going to be calculated from the sample data, and the resulting number then can be used to estimate the true value of the corresponding population parameter. So if I'm going to take a random sample of 10 employees, then the mean is going to be obtained from this random sample, and the point estimate does not provide any information about how to close the point estimate, and this point estimate does not consider the sample size and variability of the population from which the sample was taken. So like this we are going to be consider this, and so this point estimate does not provide any information about how to close the point estimate, and does not consider about the sample size and variability of the population. So the sample size and variability of population will affect the accuracy of this estimate, so that a point estimate is really not useful. So this should be the drawback of that point estimate. And this problem can be solved through interval estimates. Okay. So the sample size and variability of the sample is going to be affect the accuracy of the estimation. So the point estimate is not going to be used. That should be one of the drawback of this. And in order to overcome this, we're going to have the concept like interval estimate. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.